Let's try that again. All right, let's try it again. I know that the calendar goes into your stream, but I wanted to go over it. So I'm going to show you real quick just a couple of the discharge tubes that I used in the lab. And quantum number review page is in your feed. I also put in some slides, a slide thing for practicing on electron configurations. We're going to do some of that together, and then there'll be one you need to do and submit tomorrow also. And then if you haven't finished the spectroscopy lab, you need to do that. So again, Thursday's the partner final, Friday is on your own. Again, probably 60 points each day. You need a way to write down and show me setup for calculations. You don't have to do it by hand, but you need to be able to show how you set it up. Probably density, for sure, the wave formula C equals lambda nu, for sure, E equals H nu. You'll need to be able to upload a picture of your handwritten work into the Google form, okay? So again, any questions that you have right now? Is anybody interested in office hours at 9 o'clock tomorrow? Again, put it in the chat or let me know. We're going to pick up where we left off yesterday on electron configurations. So this is the note sheet. This will be useful for filling in. If you took notes yesterday, this is what you need to fill in on the quantum number review table. Okay, so what do quantum numbers tell us? What's the second one? All the stuff that we've gone over. And there's 2 questions down here to type in your responses to. Okay, so that's one item. And then the other item I would like you to pull up right now, please. And that is this electron configuration Google Slides. So bring that out and up on your screen so you can see what I'm doing. Either make 2, split your screen, make 2 windows, however you need to work it to make sense for you. I'm going to get this out of the way. And bring this up. Okay, so we'll come to this page. I went ahead and put a periodic table on here and a copy of the orbital, the sublevel blocks on the bottom. The actual work is going to be on these next pages. So I want to go through and do a couple of examples with you, and then see how we're doing. Okay, so we left off about here, more or less. Let me plug in my little tablet again and see if I can make it work. Hopefully that was helpful. Okay, so again, the nucleus will be down at the bottom of this diagram, and this one's intuitive because low energies at the bottom and high energies at the top. And if we pick an element, and I'm just going to pick sodium. That's another thing you want to make sure you remember your element symbols and names, because there'll be some questions about that. So remember, sodium isn't S. S is for sulfur. Na, natrum, is sodium's old name. So if we go back to a periodic table, we can find sodium right here in the first column. And the process that you want to use for doing electron configurations goes something like this. You want to know what layer it's on. The official name for layers is period. Okay? You also want to know its atomic number, because that's the number of protons, which equals the number of electrons. Okay, so let's go back and look at the periodic table again for sodium. Sodium is element 11, and it's on the 1, 2, 3rd line. Okay? So my beginning, I know that there are 11 electrons that have to have a home, and it's on the 3rd line. The other thing I know about sodium is it's in, I should have included hydrogen, there we go. It's in the S block, and it's in the 1st column of the S block. So I know that sodium's last electron goes at the 3rd energy level in an S orbital, a spherical orbital, and there's only one lonesome electron in there. Okay? These numbers are not exponents. They're in the position of an exponent, but they're not exponents. Okay? They're a count of the electrons. So sodium has 11 electrons. One of them is up here. That means there's 10 more electrons that need a home. Remember, the Aufbau principle says you've got to fill the lowest energy levels underneath, make your foundation. So we start at the bottom, closest to the nucleus, and every one of these boxes is an orbital. Every one of these boxes can have 2 electrons max. Well, conveniently, 1, 2, 3, 4, 5, 6, 7. Remember, I go one at a time in the same direction, whatever it is, positive spin, negative spin, that's the, that's seats on the bus, that's Hund's rule, okay? And then I double up if I need to, which I do in this case. So we've got 2 on the 1st level, 2 plus 6 is 8 on the 2nd level, and 1 on the 3rd level, and those add up to 11. So what do we do next? We need to, I don't know if I can get this to make an eraser. No, okay. So the next thing we're going to do is say, the 1st energy level S orbital has 2 electrons. The 2nd energy level S orbital also has 2 electrons. The 3p orbitals at the 2nd energy level all have 2 electrons. 3 times 2 is 6. And then we tag on this last lonesome electron. And this is the electron configuration notation for sodium. 1s2, not squared, 2s2, 2p6, 3s1. If you add the numbers that are superscripts, you get 11, which is what sodium has. Take that off and plug it back in and see if it goes away so I can clear that. No, it's not going to. All right. So again, the trickiest part is at the 3rd energy level, all the S's are in the right positions, okay? All the S's are, the 3s is bigger, higher energy than the 2s, the 1s is below them all, 4s is above the 3s. However, there's this weird little thing that happens when you get to the 4th energy level. The S orbital only gets 2 electrons. These D's get 10. And those 10 electrons are all negative. They're all repelling each other. They don't want to live next to each other. So it takes just a little bit more energy to keep them in there. So again, I'm going to go back to the periodic table. Whoop. first energy level is 1s only. Hydrogen's 1s1, helium's 1s2. These are the 2s orbitals. These are the 2p. The last electron goes in those. 3 s's, 3 p's. 4 s's, I don't really show up very well, does it? 4 p's. However, let's see if I can change colors. Wonky wonk. What's up? One more time. Green's nice, but it doesn't really work very well on top of lime green, and I can't change it. So these are the 3D. Remember, D's 1, 2, 3, 4, 5. D's is with the donut thing. And so the 4s has slightly lower energy, then it goes 3D. So on one of these pages, I have the, we'll come back to this. It's a little ways in. All right, let's do this one first. So again, we have sodium, element 11. Excuse me. And this is nice, and it's included on the slide deck. Excuse me. Because it has it in order for you. So you would imagine the nucleus here. This is the low energy. This is the high energy. And 1s has 2, 2s has 2, 2p's have 6, 3s has 1. So this is already in order to make it easy until you get the hang of it. And notice here's the 3D in between the 4s and the 4p, just like the periodic table. So the first line of the periodic table has 2 elements. The second line of the periodic table has 8. The third line also has 8, but the fourth line has 18. Okay, and all the lines after, well, except for 5 and 6, it gets messy, have 18 as well. Again, you list the quantum number, you list the sublevel, which is the shape, and then you put a superscript to tell how many electrons are in that sublevel. Some people find this easier to follow. You can do these little 1s, 2s, 3s, 4s, stack all the sublevels like this. Okay, so here's all the s's, here's all the p's, here's all the d's, here's the f's. And start from the bottom and go up. 1s fills, then the 2s fills, then the 2p and the 3s, then the 3p and the 4s, then the 3d, 4p, 5s, 4d, 5p, 6s. If it makes sense to you, that's an easy way to keep your order straight. Some books have it going down. It really doesn't matter. Okay, this is in line with how it looks on the periodic table. Period 1, hydrogen. And then you just go down, 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 and do the same thing, only in the downward motion. Whatever one makes more sense, if it works for you. This has the low energy at the bottom, high energy at the top. This one has it like the periodic table. Okay. Right. So that's all I want to share right now on this concept. I want to do some practice with you next. Does anyone have a question I can answer right now? Please feel free to unmute. Please feel free to type it in the chat. Where do I post these videos? I post them on our page. I think I got the video from yesterday. Absolutely, Martin. I will get this in there. I posted. I have to download it and then post it to YouTube, and it has to process. And then we got the call about my father-in-law last night, so I forgot to put it on. But in our classwork, here are, I've been putting them here like this. Okay, so it's on YouTube. Obviously, you can fast forward through it if you need to, if you don't want to watch the whole thing, which I'm sure you don't. but I will get yesterday's on and then today's as well. Thank you for asking that. Anybody else? Welcome. Okay, well, please open up this if you haven't already, like I asked you to. And then because it's kind of small, it's really hard for me, so I'm going to zoom in. Oops, maybe not that much. Let's try that. Let's try one zoom. There we go. So these are like what we've done previously. These little shaded boxes are places to make this bigger. I don't know how. I am definitely not as creative as Nikki Wilkinson, but I tried this morning to make something for you to actually do. So this is a space to type the element. This is a space for the number of protons, which of course is equal to the number of electrons. Then we start with what we went over before. So these little yellow boxes can be moved around. Maybe. And to fill up an orbital, for example. Okay, so 1, 2, that's 2 electrons. And then these are single slashes. You won't need all of these, but I put a bunch on each page, so there were plenty to go around. Okay, then you can also use those same things for going across on the compact filling. And then this last part is where you would type in the notation. So remember to do superscripts or exponents. You do, I think on your Chromebooks, it's control period will make you go up and make a smaller, an exponent type thing, but you have to hit control period again to get out of that to normal font, okay? So let's try one together. And let's do, I'm gonna pick some elements. Also, again, I have a periodic table for you. Okay, so let's do aluminum. And so I'm gonna go here, okay, and I'm gonna type in Al, because that's the symbol for aluminum. When you look for aluminum on the periodic table, it's right here, and that is really small and fuzzy, but hopefully, well, I'll just tell you it's number 13. Okay, so that means if its atomic numbers, oh, this box has to be bigger. If the atomic number is 13, then there's also 13 electrons. Okay, so you're gonna have to make the boxes bigger, I apologize. Okay, the next thing you're gonna wanna know about aluminum is where does it live on the periodic table. Helium's line 1 or period 1, period 2, aluminum's on period 3. Okay. And so the third line, it's in the P block. And again, if you're not sure, they're down here. Okay, element 13 is in the P block. So we'll go back to this. Its principal quantum number is 3. Its block is P. Where does its last electron go? Its last electron. And it's also in the first column of that block. So the last electron is going to go 3p and do control. Mine is command on my Mac, but I think it's control period. And put a 1 and then hit control period again just for the sake of hitting it again. Okay, so I know that aluminum's last electron goes here. So I'm going to take a slash and drag it over. Okay. I know that because of off bow, these all have to be filled. So again, drag over some X's because those are 2 electrons. I don't have a mouse, so this is a little tedious, but you might not either. And we have them all ready to go here. And then one more. So I'm going to pick all of those and move them to 2P. So in the 1s I have 2, and the 2s I have 2, and the 2p I have 6, and then in the 3s I have 1. Same process down here. I don't know why I can't make them just drag. It's really annoying. Hopefully you're able to do this too. I do want you to have the example on here. And let's do 3 of them. Well, I only got 2, but that's all right. Oh, that doesn't quite fit. That's okay. Ah! What the heck? You're a stinker. This is a stinky thing. OMG first. And one more. Yes.
I think on yours you might have did it wrong. I think you put the slash on 3S1, not 3P1.
You're so right. Who is that? What is that?
It's Luke.
Luke. Oh my gosh. That's hero points. You are correct. Oh, gravy. All right. Thank you, Luke. Thank you for saying it so politely, too. You're wrong, Sketches. I think you put it on the wrong one. That's nice. All right. Thank you. Oh, my goodness. That's a bad teacher. Okay. Thank you, thank you, thank you. That shows you're very engaged and you're very respectful. All right. Beauty. And then the last one. It's tedious. It's a little bit slow. Hopefully you guys are better at this than I am. All right. So, oh, I know why. I was thinking, I don't know why. I was thinking the wrong element. Okay, 2, 4, 6, 8, 10, 12, and 1 makes 13. 2, 4, 6, 8, 10, 12, and 1 makes 13. Yay, we've got the right one. So this time we're going to do 1S, command 2, and then here you have to do it again, space 2S, 2, space 2P6, space 3S2, space 3P. What? No, 3P1. Okay. 2 and 2 and 6 is 10, plus 2 is 12, plus 1 is 13. All right, I'm going to call on somebody. Any questions right now? All right, I'm going to call on a random P, and I'm going to ask you to tell me where the last electron goes. Well, now it will be simple. We'll go nice here. So I'm going to do this. Let's go to your next slide. I'm going to ask you, how many protons does potassium have? And the person is Jasmine. How many protons for potassium? Jasmine's here. Oh, yep, Jasmine's here. You can type it in the chat.
19.
Beautiful. Okay, and so potassium is another one that has a weird symbol. K, has 19 protons. middle part. I'm going to fix that before next period. Sorry, you guys get the beta version. And then there's also 19 protons here. Right, next question. What period is potassium on? Kennedy. What period is potassium on? Is Kennedy here? Whoop, Kennedy's not here. Let's try again. What period is potassium on? Kimberly. Oh, no K's today. Okay. All right, let's try it again. Tyra. Oh, why did I picked all the K's? That was idiotic. Alexa. Are you here? Yay. What period is potassium, Alexa? What line is it on? Somebody help Alexa. Oh, there you go. It's on the fourth one. You're close. So potassium is hydrogen's 1, lithium's 2, sodium's 3, potassium's 4. So that means, and it's also in the S block. And so its last electron, because it's in the first column of the S block, is going to go 4s1. And so that last electron, let's see if I can get it in the right spot, is going to go here. And again, all the other layers have to be full. So since it has 2, 2, 6, 2, 6, that gets us to 18, plus 1 is 19. We know that all of these other boxes are doubled up. Do you guys want me to fill them all in, or are you good? Speak honestly. And again, they're going to fill in low energy first, high energy later. Do this. And you can fill them all in all the way up. 2, 4, 6, 8, 10, 12, 14, 16, 18. Last one's 19. You would end here on this diagram. And then the tricky part again is getting this piece correct. If it helps you, start with the last one, but it might help you just to go 1s2, 2s2, 2p6 like that. And you guys need me to finish, or are we getting the hang of this a little bit? Oh, that's what happens if you don't turn it off. Have these typed in on yours, and then I'm going to give you one more for practice on your own, and I will stick around if you would like to check your work. That's the electron configuration for potassium. And of course, all these other ones would be filled in, but I don't want to take the time to do that if you don't need me to. Getting the hang of it. Yay! Thank you, Ava. Anybody? Does anybody need me to check your work? All right, I'm going to go ahead and stop recording because I don't need to be. And I will put this, like I said,